Hello everyone, welcome back to our Lee County Library Science Club. It's great to have you with us once again. Just want to remind you, please make sure you have your parents' permission and some supervision when you're doing these experiments with us. Today, we're not actually going to learn any new concepts. We're just going to go over some old concepts that we've talked about already that maybe you missed. Now, chemistry is a pretty large branch of science. There are lots of different directions and options that you can go for study in chemistry. But there's a few key concepts that touch all of chemistry and that you really have to know before you can do any of the other stuff. And we've talked about a few of those already. One of the most important ideas in chemistry is the concept of polar and nonpolar molecules, which we've talked about here. Okay, we've said water is polar and oil is nonpolar, right? We've talked about the structure of a water molecule, how it has one large oxygen atom and two smaller hydrogen atoms, and the way they bond creates this sort of L shape. And because it's not a balanced structure, we end up with the electrons spending more time around the bigger oxygen atom and less time around the smaller hydrogen atoms, right? So we said we end up with this oxygen end being mostly negative and the hydrogen ends being mostly positive because of the relative position of the electrons. And so water has polar molecules. They have a negative and a positive end, and it causes attraction and force between molecules. An oil molecule, on the other hand, the structure is much more balanced, and so the electrons are spread evenly throughout the whole molecule, and there ends up being no positive or negative side. It's just a neutral, balanced molecule. And we've talked about how these polar and nonpolar molecules, they can't mix, right? They can't become a solution. And a solution is a homogeneous mixture of two different substances where they mix at their most basic level. So you have actual molecules intermixing with each other in a solution. And because of the polarity, water and oil are unable to mix. Now, the other key concept that we're going to recap today is the idea of density. And as we said before, density is the amount of stuff within a given space. Right? We said how solids, like this table, are more dense than liquids, like this water, which are then more dense than the air floating around me, right? Because there's just more space between the molecules in air than there is in water, which then still has more space between the molecules than this nice solid table. So the other way to think about density is how tightly packed the particles are. And if you'll remember, we also talked about how different substances can be in the same phase, like they're both liquid, but they can have different densities as well. And in this case, water is more dense than oil. So if you put the two in the same container, what's going to happen? Well, because there's more stuff in that area with the water, then gravity is able to pull more on the water than the oil. So when they're in the same container, the water will go to the bottom and the oil will float to the top, right? Because the water is more dense and therefore gravity acts more strongly upon the water and pulls it down below the oil. So we're going to take these two concepts today, the idea of density and how different things can float or sink with their relative densities, and then the idea of polar versus nonpolar means that those substances don't mix. And we're going to use these concepts to create our homemade lava lamp. Now, the lava lamp that you buy at the store, that does work on density as well, because, you know, it has a lamp at the bottom that heats up the substance inside, and as it heats up, it gets less dense, right? Because the molecules inside have more energy and are moving more, and so as it gets warmer, it's getting less dense until it gets light enough to float up to the top of the lamp. And then once it's at the top, it's far enough away from the heat source at the bottom, it cools back down, and once it becomes dense enough again, it floats back to the bottom. And you have that continuously happening within the lava lamp. Well, we are going to do something similar today. Now, we're not going to use heat to make it move, but we're going to use the relative densities of water, oil, and actually carbon dioxide to create our very own homemade lava lamp. So what you'll need is some vegetable oil or baby oil. You'll want a container that has clear, clean, nice smooth sides, okay? And you want to fill it a little bit less than halfway with water. You'll need some kind of fizzing medical tablet, like this is Alka-Seltzer. You want some food coloring as well. Now let's make it happen. Now the first thing we're going to do is make our water some kind of fun color. You want to make it a pretty good contrast to whatever color your oil is. So I'm going to put a few drops of red food coloring in here. Make it a really nice deep dark red. There. Now we've got a nice vivid red color in our water. Next, I'm going to pour the oil on top of the water. Now you want to do this kind of slowly and gently so that the oil doesn't collapse into the water and cause it to mix up. And fill the oil up most of the rest of the way in my container. There. So now you can see we've got a pretty clear difference between the water on the bottom and the oil on top. Now, as we talked about, the water and the oil, they won't mix together because water is polar and oil is nonpolar. But they also sit on top of each other because oil is less dense than water. Now, what is going to happen when we take our fizzing tablet and drop it in here? Well, the reaction between this tablet and the water releases carbon dioxide. Carbon dioxide is the gas that we breathe out whenever we breathe, right? We breathe in oxygen, and our body uses it, brings it to our muscles, gives us energy, helps us move, makes our body function, and then it goes back, and we breathe it out in our lungs as carbon dioxide. So carbon dioxide is the gas that's going to be released when we drop this in here. Now that gas is less dense than both the water and the oil. So it is going to float up to the top. But as it floats out of the water is going to form bubbles around it, right? Because as we've learned, water is both cohesive and adhesive. So it's going to stick to the carbon dioxide air and form a bubble around it, which will then float to the top. Now what happens when the water reaches the oil? Well, that's what we're going to find out. So I'm going to drop the pieces in here and we're going to watch. You see those bubbles start to form? Now as you can see, the water is now, because there's only a little bit of water around those bubbles of gas, the water is now going to float through the oil to the top. But when it reaches the top, what happens next? Well, the bubble of water breaks and the gas escapes out of the top. So now we have water again with the oil, but without that gas. So now the water forms itself into a smaller bubble and floats back down. And so now you can see we've got water and gas bubbles floating up and then water bubbles floating back down. And you can get an idea of the color as they move. You can see there's some slow moving ones floating back down to the bottom. So when you're working on any kind of chemical reaction or creating some sort of chemical mixture like medicines or other chemical compounds, these are a couple of the things that you really need to know before you start mixing and making those reactions. You need to know if this substance is polar or nonpolar, and you need to know the relative densities between the two substances. Now, there are lots of other things that you really need to know to work on specific chemical reactions. But, as I said before, in all the different branches of chemistry, there's a lot of specific knowledge to what you're working with. But all of them need to know some of these basic foundational concepts of polarity and density. Thank you so much for joining us today. I hope you enjoyed it, and we'll see you next time. Bye!